Hello everyone, I welcome you all back with my new video. In this video today we are going to learn detailed revision of next chapter, that is arithmetic progression. So let's begin with our this chapter. The very first question that arises when we talk about this chapter is, what is an arithmetic progression? Basically, a progression is a list of numbers that are so systematically arranged that when we consider any two consecutive numbers of the list, we can see a certain relation between them, and that relation is maintained throughout the list, and because of that we can see a certain progression in the list. That progress may be in the form of ascending order or descending order. And when we particularly talk about arithmetic progression, the relation between any two consecutive numbers of the list is expressed using two basic arithmetic operations, namely addition and subtraction. Yes, we do have other progressions, namely geometric progression and harmonic progression, which is not in the scope of our discussion. Now let us see what is the definition that is provided in your textbook about the arithmetic progression. An arithmetic progression, which is indicated by AP, is a list or series of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This definition gives us one important point, that first term can be anything. An AP can have first term anything that can start with any number, and a certain fixed number we are adding to obtain a certain list, that is known as arithmetic progression. Let us see this with an example. I am going to consider an AP here, which is 1, 2, 3, 4, 5, 6. Let us see what are the components that are present in the list. Here, first term is 1. You can see the first term of the AP 1, that is usually denoted by letter A, or also known as A1. And each number of the list is called term of the given AP. If we consider 2, this is second term of the AP. Likewise 3, this is third term of the AP. Likewise, each and every element or number of this list is known as term of the AP. We are going to use these words in future learnings, so kindly remember these terms. Now, one question arises, is there any rules that there should be a particular number of elements that should be present in the AP? Let us see. An AP can be finite AP or infinite AP. Now, what is this finite AP or infinite AP? Let us see. First, we will talk about finite AP. An AP is having finite number of elements. Such APs are called as finite APs. Let us see this with an example. I am going to consider an AP here, 1, 5, 9, 13, 17. In this AP there are only 5 terms, hence this is a finite AP. You can see there are only 5 terms that are present in the AP, and that AP ends here. Hence this is known as finite AP. Any AP that is having an end, that is known as finite AP. If an AP is not indicated by dots at the end of the AP, that is known as finite AP. Means number of elements of that AP are finite. Secondly, infinite AP. If an AP is having infinite number of elements, such APs are called as infinite APs. Means when I consider an AP here, 1, 2, 3, 4, 5, 6, and that list is continuing. There is no end for this list. Basically, this is a group of natural numbers. Similarly, we have other groups also called as list of even numbers, list of odd numbers. This is an example of infinite AP. Here there is no end for the AP. You can see the last term of the AP and it continues with dots. If you see any AP that are continued with such dots, then you should identify that AP as an infinite. Now we are heading towards an important concept, common difference of the AP. Now in the previous definitions I have explained you, when we consider any two consecutive numbers of the AP, we can see a certain relation between them, and that relation is basically expressed in the form of two basic arithmetic operations, namely addition and subtraction. In the same way, when we consider difference of any two consecutive numbers of the AP, that difference itself is known as common difference of the AP. Now let us see what is the definition provided in the textbook. The fixed number that is added to each term is called as common difference of the AP, and usually that is denoted by letter D. Now we are adding this fixed number to obtain the first number to get the next number. So such common difference is also known as fixed number. Now let us understand this with an example. In the previous example, I have considered AP as 1, 2, 3, 4, 5, 6, and that is continuing. Now here, how to obtain the common difference in this AP? Let us see. Now we usually take the common difference D as A2 minus A1 or A3 minus A2 or A4 minus A3. Likewise, we get the general formula to obtain D, that is D equal to an minus 1. Here n indicates the position of any term. For example, if I substitute n as 1, I get the first term of the AP. If I substitute n as 2, I get the second term of the AP. And basically in this formula, if I take an minus 1, which means that if I am taking an as any term, an minus 1 will be the preceding term to that an. Now when we take the difference of those two terms, basically we are talking about consecutive numbers. When we take the difference of those two consecutive numbers, that will be same throughout the AP. Therefore, let us see in our example D equal to A2 minus A1 we are considering, that is 2 minus 1. We are getting answer as 1. Similarly, if I consider A3 minus A2, that is 3 minus 2, that is also I am getting as 1. Similarly, A4 minus A3, that is 4 minus 3. Again I am getting the same answer as 1. Hence, when we take the common difference of an AP, we always get the same answer. Now, common difference can be either positive, negative or 0. Now, what is this positive, negative or 0? Let us take examples for each type of common differences. Now, these examples are going to be very important exam point of view for 1 mark. Directly, these questions will be asked like find the common differences of the AP. Now let us take example for positive common difference. Here I am going to consider an AP 2, 5, 8, 11, 14, 17. Here how to find D, that is common difference. D is usually found by, we have seen in the last slide, that is A2 minus A1. Now I am going to consider here second term minus first term. Second term is 5 minus first term is 2. 5 minus 2, I am getting answer as 3. Here, since 3 is a positive number, this is identified as positive common difference. Therefore, this is going to be an example of positive common difference. Now, one noticeable fact in this example is whenever you see an AP that is in ascending order, you can identify that AP as an example for positive common difference AP. Now we are going to head towards the next example. In this I am considering an AP minus 9, minus 7, minus 5, minus 3, minus 1, 1, 3, 5 and so on. Here, even though we can see the numbers that are ascending in order, even this example is considered for positive common difference, because if I see the direction of movement of these numbers, they are starting from left side of the number series, that is in the negative zone, and they are traveling towards positive zone, and once they cross the 0 milestone, they are going to be even seen in the form of ascending order. Here you can see once it crosses from minus 1, it is reaching plus 1 here. Now here onwards you can see that 1, 3, 5, this is in the form of ascending order. Now here in this example, if you want to calculate D can be found again by using the formula, that is A2 minus A1. Here second term, that is A2 is minus 7 and the first term, that is A1 is minus 9. If you want to take the difference of these two numbers, minus 7 minus of minus 9. Whenever you have any term with negative sign, have an habit of keeping those numbers in brackets. When I consider this D here, minus 7 minus of minus 9. Now this minus into minus becomes plus. Therefore D is equal to minus 7 plus 9. Since 9 is the bigger number, I am subtracting 7 from 9. When we do this, I am going to get the answer as 2. Now this 2 is positive number. Hence, again this is an example of positive common difference. Let us go ahead. Now I am going to take the examples for negative common difference. I am going to consider an AP here, 10, 8, 6, 4, 2, 0. Here again d is equal to a2 minus a1, that is second term minus first term. My second term is 8 minus first term is 10. 8 minus 10. I am going to get the answer as minus 2 here. Since this minus 2 is a negative number, we are going to identify this common difference as negative common difference. Again, one noticeable fact in this example is we can see an order of descent or descending order here in this AP. Therefore, if you see an AP with descending order, you can identify that the common difference that is going to come from that AP is going to be example for negative common difference. I will take one more example here. Minus 3, minus 5, minus 7, minus 11 and minus 13. Now you can see if you consider only numbers, that is going to be in ascending order. But because of that negative sign, that direction of travel of those numbers is in the left side of the number series. And even though numbers are ascending, because of those signs, that is negative sign, we are seeing these series as descending series. Therefore, you can see if you want to calculate common difference here, d is equal to again second term minus first term. My second term is minus 5 minus first term is minus 3. So I am going to put it as minus 5 minus of minus 3. Now again this minus into minus becomes plus, minus 5 plus 3. Minus 5 plus 3, we are going to get the answer as minus 2 here. Since again this minus 2 is negative number, this is an example of negative common difference. Next, we are going to take example for zero common difference. Here I am going to consider an AP. If you see any AP in which all the terms are identical, such APs are going to be example for zero common difference. Now if I take E7, that is second term minus first term, second term is 1, again first term is also 1. If I take the difference of these two terms, I am going to get the answer as 0. Therefore, such examples are considered for zero common difference examples. We have been studying mathematics since the beginning of our school days, and we have observed one fact that whatever we study in mathematics, we have a certain formula for that thing. Similarly, we are going to have a general form of an AP. Means if a set of number is given to us, in order to identify whether it is an AP or no, we are going to have a certain formula, or that formula is known as general form of an AP. If that list of numbers is present in this general form, and then you can declare that list as an AP. Now let us see what is that general form. That general form is A plus D, A plus 2D, A plus 3D. This is known as general form of an AP. This is also an important question exam point of view that can be asked for 1 mark. The question can be like, write the general form of an AP. Then you will have to write this general form. Here, first term is indicated by letter A and second term is indicated by A plus D, which means if I am going to add D to first term, that is A, I am going to get the second term. Similarly, this is third term and this is fourth term, and it continues. This general form gives an idea of how to get any term of an AP. Means any term means you know that there are n number of terms that are present in an AP. If I want to get any term that I wish to see, how to get that term, even that is if that is not indicated in the question. Let us see how to get that term. If 1 times of D is added to the first term, that is A or A1, we get the second term. Let us see here. I am adding D to A, means 1 time of D I am adding to the first term, then I am getting second term. Similarly, if we add 2 times of D to first term, we get the third term. You can see here, this is the third term. I am adding 2 times of D to the first term, then I am getting third term. Similarly, if I add 3 times of D to the first term, I will get the fourth term. Similarly, if I add 4 times of D to the first term, I will get the fourth term. Likewise, it continues, and this one certain pattern is seen throughout the AP. That is why this is known as general form. Means generally we can represent this AP in this form. That is why this is known as general form of an AP. For example, here I am taking an AP 2, 5, 8, 11, 14 and 17. Now if I first find the common difference of this AP, that is going to be A2 minus A1. My second term is 5 minus first term is 2. 5 minus 2, I am going to get the answer as 3. Now suppose I want to calculate the third term. Let us verify whether this our general term is correct or no. Now here second term I want to get the second term, that is 5 in this example, whether I will get using this formula or no. As per this definition, if I add one time of d to the first term, I will get the second term. Let us see that. Here first term is 2 and common difference is 3 here. So I am adding 1 times of common difference, that is 3, to first term, that is 2. So 2 plus 3 I am going to get answer as 5. That is going to be my second term, you can see in this example. Similarly, let us verify with third term. If I add 2 times of d to first term, I am going to get third term. Let us see here. I am adding 2 times of d, that is 3, to the first term, that is 2. So when I do this, 2 plus 6, I am getting answer as 8. Again you can see that third term in this AP is 8. Therefore, this is how we can obtain any term that is not given in the question. For example, in this AP, terms are available only up to 17, that is 6th term. If I want to get the 7th term, that also I can obtain by adding a plus 6 times of d. Then I will get the 7th term. Likewise, we can obtain any. In previous slide, we have seen general formula for an entire AP. In this particular slide, we are going to see particularly for any one term of that AP. Here, we are going to see formula to calculate nth term of an AP. Now, this is going to be very important formula exam point of view, which has been asked many times in the examination. Straight away asking, write the formula to calculate the nth term of an AP for 1 marks. Now let us see what is this nth term is. Nth term is any unknown positions term of an AP. For example, if I want to calculate 10th term of an AP, which is not indicated in the question. So 10th term, if I want to calculate, that is going to be our unknown position. So n value is going to be 10 here. So let us see what is that formula is all about. Formula states an is equal to a plus n minus 1 into d. Here, what are the terms present in this formula? Here an is equal to value of the term present at the nth position. Means if I put an is equal to 10, that is going to indicate the value of 10th position of an AP, which we want to calculate here. Now a you have already seen, that is it as the first term. N is going to position of the term which we need to find the value of. For example, 10th position I need to find the value, therefore n value is going to be 10 here. Now d is equal to common difference here. Let us understand this formula with an example. I am going to consider an AP here 2, 5, 8, 11, 14, 17 and that is continuing. This is an example of infinite AP. Here first we need to find the common difference. D is equal to second term minus first term. Second term is 5 minus first term is 2. 5 minus 2 I am going to get the answer as 3. Therefore common difference of this AP is going to be 3 here. Now if you want to find the 10th term of this AP, there are only 6 terms that are given in this AP. Now I want to find the 10th term. So this is what our unknown positions term is all about. Therefore let us take down all the given data first. That is a is equal to 2, that is first term. N is equal to 10, means I want to find a 10th term, therefore n is going to be 10 here, and common difference we have just found out, that is d is equal to 3. Now we are going to substitute all these values in our formula, that is an is equal to a plus n minus 1 into d. In wherever n is there I will put 10, wherever a is there I will put 2, wherever d is there I will put 3. So when I substitute all the values I get a10 equal to 2 plus 10 minus 1 into 3. When I do 10 minus 1, I am getting answer as 9 here. First, I am going to solve the terms that are present inside the bracket. This is because of Bottom's rule. What is Bottom's rule? I am going to explain in future slides that I am going to when I am going to take the examples. So I am going to solve firstly that are present inside the bracket. 10 minus 1 is going to be 9. Now I will multiply that 9 with this 3. 9 into 3 is going to be 27. Now then I am going to add 27 plus 2 is going to give me the answer as 29. Therefore 10th term of this AP is going to be 20. Now let us understand and make a note of few key points. That is, in general, an is equal to an minus 1 plus d, which indicates that if I want to calculate the fourth term, then I need not have the first term essentially, which means if I have third term and the common difference, I can directly find the fourth term. So that is, in general, we can express it as an is equal to an minus 1 plus d. Next, an is called the general term of an AP, which means if I put n is equal to 1, that is going to give me value of first term. Put n is equal to 2, that is going to give me value of second term. Likewise, as I go on changing value of n, the value of this entire term is also going to be changed. Therefore, this is known as general term of the AP. Next, in case of finite APs, the last term is denoted by letter L. For example, in previous cases we have considered many finite APs. In that, first term is indicated by letter A and the last term of that AP is indicated by letter L. Obviously, when we consider infinite APs, we do not know the last term, so we do not have any value of L there. Next, the following formula can be derived from the formula, that is an is equal to a plus n minus 1 into d. Now, you might have observed this thing while solving problems of your exercise, that every time we are not asked to calculate value of the term that is present in nth place. That is, an value is not asked every time. Sometimes an value is given, a value is given, n value is given, and d is asked. Likewise, mainly there are 4 terms that are present in our main formula. Main formula for calculating nth term of an AP is this, that is an is equal to a plus n minus 1 into d. It contains mainly 4 terms. Out of this, any 3 terms will be given and you will be asked to calculate the 4th term. So, in order to save your time in the examination, I have prepared these formulas directly, or I have derived those formulas using this main formula, so that you can directly by heart these formulas and apply in your exam. That is, first one, formula to calculate n when a, an and d are given. These 3 terms are given and n is asked to you. So that is going to be n is equal to an minus a upon d plus 1. That is the first formula. Next, formula to calculate d when you are provided with a, an and n. Therefore, d is going to be an minus a upon n minus 1. Next, formula to calculate a when you are provided with a, an and d. That is going to be a is equal to an minus n minus 1 into d. Now, how to use this formula and how to solve the problems? Let us take the first example on how to solve the problems using the formulas that we have derived in the last slide. Example I am going to consider. In an AP, if the first term is 7, the common difference is 2. Then which position's term of the AP would be 35? Means, first let us take down all the given data here. Here, what all things are given to us? First term, that is a is equal to 7, that is given. Then common difference is given, that is d is equal to 2. Now, we are asked which position term, means the value of that term is given, that is an is equal to 35. Now we will have to find n is equal to how much, means that value of 35 is present at which position in the AP, whether it is position in first position or second position, third position. Likewise, n we need to find here. Now, how to find this n? Let us see. First, we are going to write the formula always. Have a habit of writing the formula every time when you are solving the problem. This contains 1 mark always. First, I am going to write the formula. N is equal to an minus a upon d plus 1. This is derived from the main formula, that is an is equal to e plus n minus 1 into d. Here, now I am going to substitute all the given values. N I need to calculate, that I will keep as it is. an value is 35, a value is 7, then d value is 2, 1 I am going to keep as it is. Now here we are going to solve these problems using Bodmer's rule. You can see a lot of brackets present here. We are going to solve all these problems using Bodmer's rule. Now what is that Bodmer's rules? Let us understand. Bodmer's stands for B is bracket, O is order, D is division, M is multiplication, A is addition and S is subtraction. Now whenever we have such a difficult situation wherein multiple signs are present in the same question, that time we are going to follow this particular order. First we are going to solve the terms that are present inside the bracket, then we are going to solve any terms that if they have order, then we will do the division inside the bracket, then we are going to do multiplication, later addition, and lastly we are going to use the subtraction. Here there are two brackets present. First one is flower bracket, second one is common bracket. In this bracket, first I am going to solve inside the flower bracket. Inside the flower bracket one more bracket is there that I am going to consider. First I will solve that. 35 minus 7, that is going to be 28 upon 2. Now this one bracket is removed, only flower bracket is remaining. Now I will solve the flower bracket. So inside the flower bracket operation is division. So I will do the division. 28 upon 2, that is going to be 14. Now flower bracket is also opened. Now I am going to do the operation like addition. That is 14 plus 1. I am going to get the answer as 15. Therefore value of n is going to be 15, which means 15th term of this given AP is going to be 30. Let us take the second example on those formulas. Question states, in an AP, if the first term is 15, sixth term is 18, then what is the common difference of the AP? Let us note down the given data. First one is, first term is given, that is A is equal to 15. Then sixth term is given, which indicates A6 is equal to 18. Which means n value is also given to us, that is n is equal to 6. Then we are asked to calculate common difference of the AP, that is d is equal to how much. In our first step we are always going to write the formula. Remember that is going to give you 1 mark whether you completely solve the problem or no. So always have a habit of writing the formula first whenever you solve the problem. Now formula states d is equal to an minus a upon n minus 1. Remember, don't forget to put the brackets here. Brackets play a very important role. So always write the formula as I have given. Second step, we are going to substitute all the values in the formula. D is equal to, in place of an I will put 18, in place of a I am putting 15, in place of n I am putting 6, in place of 1 I am putting 1 as it is. Now again we are having multiple brackets and multiple signs here. So we are going to solve this problem also using Bodmer's rule. First I am going to solve the terms that are present inside the bracket. So again multiple brackets present here. First I obviously need to solve the flower bracket. Inside the flower bracket when I enter, I am going to see again 2 more brackets here. So I can simultaneously solve those 2 brackets. First when I solve 18 minus 15 I am going to get answer as 3. When I solve 6 minus 1 I am going to get the answer as 5. Now I am left with one flower bracket. Inside the flower bracket I have division operation, that is 3 divided by 5. When I do 3 divided by 5 I get the answer as 0.6. Now you can keep the answer as it is, like d is equal to 3 by 5, or you can keep it in the form of decimal, that is d is equal to 0.6. Now here you can say that the common difference of this AP is 0.6. Means if you go on adding 0.6 to each term, you are going to get the next term. Let us take the third example, which we are solving in order to understand the formulas that we have derived before. The problem states, if the 8th term of an AP is 27 and the common difference is 3, then what is the first term of that AP? Here let us take down all the given data first. Given d is equal to 3, that is common difference. Then 8th term is given to us, that is 8 is equal to 27. From this we directly get n as 8. Now we are asked to calculate first term of this AP. So as the first step of our solution, we are always going to write the formula again. Now I will substitute all the values inside the formula. An is equal to 27, n as 8, d as 3. Again we have flower bracket here. Using BODMAS rule, again we are solving. First I solve inside the flower bracket. There is one more bracket that I am going to solve. 8 minus 1, I am going to get the answer as 7. Now I am left with only one flower bracket. Now I will solve that flower bracket. Operation inside that flower bracket is multiplication, that is 7 into 3. 7 into 3 is 21. Now I have opened this flower bracket as well. Now as last step I am taking it as a is equal to 27 minus 21. When we do this subtraction, we get the answer a is equal to 6, which means first term of our this AP is going to be 6. Now this is the last example that we took to understand these all the formulas that we just derived. Now you can check the credibility of all these three formulas by solving problems that are present in your exercises that I am going to leave to you people, so you just try. Now we are going to see a very important concept of this chapter, that is sum of first n terms of an AP. Suppose you are given with an AP and you need to calculate sum of all the terms that are present in that AP. Suppose you are given with first 5 terms of that AP and you want to calculate sum of all those 5 terms. Then you can do it by doing simple operation like addition, that is A1 plus A2 plus A3 plus A4 plus A5. Then you will get sum of first 5 terms of that AP. Suppose in second situation you are asked to calculate sum of first 25 terms of an AP. In that case, if you want to do it by normal addition, you have to go for writing all the terms of that AP first, then you can do simple addition and find the sum. But there are certain formulas that have been previously derived, using which you can directly find the sum of all those 25 terms using the formula and depending on given data. So we have certain formulas. Let us see what are those formulas. First one is when you are given with first term of an AP and you are given with n up to which you have to find the sum, and common difference d of that AP is also given. In that case you can find sum of first n terms, that is Sn, equal to n by 2 into 2a plus n minus 1 into d. Using this formula you can find sum of any number of terms even without knowing actually all those terms. Next situation, when you are given with first term a, number of terms up to which you have to find the sum, and nth term is also given to you. That case d is not given. In that case also you can find sum of first n terms, that is using the formula Sn equal to n by 2 a plus an. Now we have one more situation, third situation, where you are given with first term and you are given with n up to which you have to find the sum, but nth term is not given and d is also not given, but you are given that last term of that AP is given to you, that is L. Remember, third formula can be applicable when you have a finite AP wherein first term and last terms are known and sum of n terms is asked to you. It may not be last term. Suppose there are 50 terms in an AP and you are given with first term and 50th term, and you are asked to find a sum of anything in between. Suppose sum of first 25 terms. In that case you can apply this third formula, that is Sn equal to n by 2 a plus L, where L indicates the last term of that AP. Now let us take one example wherein we are going to see how to find the sum of first n terms of an AP where first term and last term of the AP is given. And the problem states, find the sum of the odd numbers between 0 to 50. There is a chance of making mistake while solving this problem, so you need to be very careful while solving such problems. You can see that a range of number is given, that is 0 to 50, and it is asked to find the sum of odd numbers. Remember, while taking data of this question, you are going to consider a as 1, not as 0, because odd numbers starts with 1 and ends with 49. From this we can judge that a is going to be 1 and our last term is going to be 49. And in this, first you need to identify how many odd numbers will come in between 0 to 50. That is going to be n, which is not given. We can easily find out that After that you have to find the sum of those all the odd numbers that are coming between 0 to 50. So to be calculated is, first we need to calculate n, secondly we are going to calculate Sn. Step 1, we are going to write the formula here, then we are going to calculate n values. N value is going to be, there are total 0 to 50, there are total 50 numbers, out of which half are odd numbers, half are even numbers. If I want to calculate odd numbers, number of odd numbers, 50 divided by 2 is going to be 25, which means in between 0 to 50 there are going to be 25 odd numbers, out of which first number is 1, last number is 49. So we are given with all the data, required data. So I will put all the data in this equation or in this formula, and then I will directly calculate the answer. So I will substitute all the values now. Sn equal to, in place of n I am going to put 25 by 2, in place of a I will put 1, in place of l I will put 49. Therefore Sn is going to be 25 divided by 2 into 45 plus 1 is 50. 50 by 2 I got as 25, therefore Sn is going to be 25 into 25. Now we know that Sn is going to be 25 into 25 is going to be 625. So this is the sum of now we are going to see one more important concept, wherein sum of first n positive integers. We know that positive integers also form an AP whose common difference is always 1, and those positive integers have first term as 1, and up to which n we are going to consider, that is going to be our last term. So we can generally form one formula for having this idea, that is going to be sum of first n positive integers. Here if we want to consider the formula, Sn is equal to n into n plus 1 upon 2, hence n is going to be up to which positive integer you want to calculate the sum. For example, I want to calculate sum of first 10 positive integer, there my n is going to be 10. So example, here only I am taking the example. If I want to find the sum of first 18 positive integers, here I am going to substitute all the values. Step 1, I am going to write the formula or as always, then I will put n is equal to 18, inside the flower bracket I am going 18 plus 1 divided by 2. 18 plus 1 is 19, that is going to be 18 into 19 by 2. Therefore 2 I am dividing 18 by 2, that is going to be 9. 9 into 19, that is going to give me answer as 171. Therefore sum of first 18 positive integers is going to be 171. Again you can check the credibility of this formula considering different positive integers. Now let us see a special formula to calculate common difference D of an AP. Suppose while solving some exercise problems, we have come across problems wherein any two non-consecutive terms of an AP is given, and in that case A is also not given. So we have to find common difference in such situation. We have solved such problems maybe by using concept of pair of linear equations in two variables. So we need not every time apply same concept. We can solve such problems in order to calculate D easily using this one formula. If only any two non-consecutive terms of an AP are given and we need to calculate D, in that case we can apply this formula. Let AP be the pth term and AQ be the qth term. These are the two given non-consecutive terms of an AP. In that case D can be calculated by D is equal to AP minus AQ, means pth term minus qth term, divided by P minus Q, that is number of their position, that is equal to, you can also take it as AQ minus AP upon Q minus P, wherein depending on the number, if pth term is greater you can take first formula, if qth term is greater you can take second formula in order to avoid negative sign in the answer. Let us understand this with an example. Suppose you are given with that sixth term of an AP is 12 and eighth term of an AP is 24, and find the common difference. Here A is not given. Even in that situation we can find D, that is by, let us take down given data. AP I am indicating as A6, that is I am taking as 12. AQ I am indicating as A8 and I am taking it as 24. Here you can see that P is equal to 6 and Q is equal to 8. Therefore D is equal to, I'm taking this formula AQ minus AP upon P minus Q. When I substitute all the formulas, I will get 24 minus 12 upon 8 minus 6, that is 12 by 2. So I have got answer as 6. Therefore, common difference of this AP is going to be 6. Now using this formula, you can avoid the concept of linear variables by elimination method. So you can easily use this formula in order to save time. Now similarly, we have one more special formula to calculate nth term of an AP, where first term, that is A, is not given, only D is given, and any one term of an AP is given. In that situation, we have been solving this type of problems using any nth term. We are solving first to calculate A, then we are solving ask the nth term of an AP. So let us see, when any one term of an AP is given and D is given, how we can directly calculate any other term of a AP. If any one term of an AP and D is given, then ask to calculate nth term. Let AP be the any given term. AP, I am indicating any given term. In that case, if I want to calculate nth term, that is AN equal to AP, means that given term, plus N minus P into D. I am going to do it. So let us understand this with an example. If fourth term of an AP is 14 and common difference D is equal to 2. Now you are asked to calculate 8th term. Normally how we solve is, we consider fourth term, that is A4 equal to 14, and using formula A is equal to AN equal to A plus N minus 1 into D. First we calculate A, then using that A we calculate 8th term, that is A8 equal to A plus N minus 1 into D. So in order to save time, we can directly calculate 8th term of an AP using this formula, that is A8 equal to A4 plus 8 minus 4 into D. Therefore A8 equal to A4 is 14 plus 8 minus 4 is 4 into 2. 4 into 2 is 8. For 8th term I am going to get as 14 plus 8, that is 22. You can solve this by using a normal method and also check whether we are getting same answer or no. Therefore you can use this formula without any fear, because this has been a proven formula. Now finally, let us see the summary of this detailed revision through list of formulas. First formula that we have seen is D is equal to AN minus AN minus 1, that is difference of any two consecutive terms of a AP. You can find common difference, that is D. Then you can also find common difference D as AP minus AQ upon P minus Q when any two non-consecutive terms of an AP are given. Next, general form of an AP that we have seen, that is A plus D, A plus 2D, A plus 3D dash dash, means first term is indicated by A, second term is indicated by A plus D, third term by A plus 2D, like that nth term is A plus N minus 1 into D. Next, using formula same common formula, that is AN equal to A plus N minus 1 into D, we can find different terms, that is N, when out of those 4 terms any 3 terms will be given. That way you can find the fourth term, that is first one is N equal to AN minus A upon D plus 1, D equal to AN minus A upon N minus 1, A equal to AN minus N minus 1 into D. Similarly, we saw a special formula, that is AN equal to AP plus N minus P into D. When any term of an AP is given and D is given, you can calculate any other term of that AP using AN equal to AP plus N minus P into D. Now we have formulas of sum of first n terms of an AP, that is Sn equal to n by 2 into 2a plus n minus 1 into D. Similarly, Sn equal to n by 2 into a plus an, and Sn equal to n by 2 into a plus l. Third formula is used in case of finite AP, where first and last terms are given and you are asked to calculate sum up to any middle term. For example, sum of first n terms in case of AP is having 50 terms. In that case, you are knowing first term and last term. Using that also you can find sum of first n terms. Now sum of first n positive integers, wherein common difference is always going to be 1. In that case you can find Sn equal to n into n plus 1 upon 2. So with this we are going to finish this detailed revision of arithmetic progression chapter. Hope you all enjoyed and revised this chapter very quickly. This is going to be very useful. Now you can also download the PPT in the form of PDF by clicking on the link provided in video description and keep it as your future reference for notes. Thank you. Let us meet in next video of next chapter. Till then, good.